Mouth noises.
Oh, don't like that. Ew, no. Ooh.
Peter Piper packed a pack of pickle peppers.
Peter Piper's pecker was pickled in the...
Warning, this podcast contains violence, sexuality, gore, and other horrible and disturbing things. Listener discretion is advised. Also, the hosts of this venture are ignorant dipshits, so please do not take anything they say as fact. And enjoy the show.
Now, are you sitting comfortably? Good. Then we'll begin.
Today we had 15 homicides and 63 violent crimes, as if that's the way it's supposed to be.
It is our basic human right to be fuck-up.
A second plane now has crashed into the other tower of the World Trade Center.
Put chemicals in the water that turn the friggin' frogs gay.
The defendant shall be incarcerated for the rest of her natural life with no possibility of parole.
You are not machines. You are not cattle. You are men.
We were somewhere around Barstow, on the edge of the desert, when the drugs began to take hold.
Occultae Veritatis.
Hello, occultists. Welcome to another episode of Occultae Veritatis podcast. Of course, if you're listening to this, you probably already know that, but if you didn't, now you do. So I am Richard Bigley, and in studio with me, I have...
Don't worry, get fucked, I'm second.
Oh, fuck. Shit. Ood Gallifrey.
And the caboose of the OVPOD train?
More like a dumper, but I'm the soundboard unit.
So it's been like over a year since we've recorded.
It's been a minute.
Yeah. So it's neat to be in the room with everyone again.
Yeah.
I'm out of prison. Sage is not in rehab. And Ood is back from his world book tour. So let's get to it.
I lost a leg. And I didn't lose a leg.
Okay.
I was never in rehab also.
Yeah.
Okay, so on the way over, I was walking down the sidewalk and I saw that there were these like two birds and they were like really, really stuck together.
Ew.
And I was like, they're making all this weird noise trying to get apart or whatever.
Oh.
And I'm like, why are they stuck together? And I walk a little closer and I kind of move the branch out of the way. And I was like, of course they're stuck together. They're Velcros.
Oh.
Well, that was the end of this. Thank you for never listening to OVPOD ever again, because we're quitting.
Maybe we should take another hiatus.
Yeah.
See you guys in a year.
Year was not long enough.
I ruined the podcast.
Again.
Everybody hurts.
Ood's book, by the way, is titled
Sometimes.
What Bigley Did, the True Story of Occultae Veritatis podcast.
What was it? Did Bigley do it?
Did Bigley do it?
Damn it, what did he do?
Oh, I got one for you, Richard Bigley. Why do the Dutch put barcodes on their ships? So when they come back into port, they can Scandinavian.
Ba-dum-ps.
Yeah. Yeah.
Okay, that's enough of that. So today, we know about the planets in our solar system, and humans have known about many of them for millennia. We'd look up to the night sky, and we saw stars that all seemed to move across the sky as the seasons progressed. However, there were some stars in the sky that were a little different. They didn't move like the rest of them. They would move one direction, and then in another direction, and then back to the other direction again, and they just wandered around the sky, and which is where the word planet came from, planan, meaning wanderer. Huh. So Mercury, Venus, Mars, Jupiter, and Saturn were identified by ancient Babylonian astronomers in the 2nd millennium BC.
Oh, they're smart.
Aristarchus of Samos had said that this was because they orbited the sun along with the Earth, and almost 2 millennia later, Nicholas Copernicus would restate this, and it would shock everyone.
That always made sense in my head. Like, people seem to question the ancients' knowledge of the sky. Like, how could people back there possibly pay enough attention to know? But
what else do they have to do?
Yeah, there was no... You couldn't doom scroll on TikTok at bedtime. Yeah. You didn't have, like, movies to go to, entertainment.
And they didn't have light pollution, so it was, like, prime viewing.
Yeah, you had a few unadulterated view of the night sky that you could just observe, and why wouldn't you observe these funny little lights in the sky that seem to follow a path year after year?
Mm-hmm. Oh, P.S. Are we doing a poison?
Yes, I'm working.
Oh, you're... Oh, okay.
I'm building up to it.
He's a
it was just a really long preamble.
He's a professional.
I'm not done the preamble.
I just gestured my cup at Bigley.
It literally says, "What's your poison?" in the fucking script.
I believe you.
I know. I'm building up to something.
He's a professional.
Yes.
Yeah, Copernicus would restate that we all orbited the sun, and that would shock everyone, even though we had known this like millennia earlier.
I do prefer Copernicus.
But this episode isn't about these planets. This is about something far cooler: the exoplanets. That is, planets that exist outside of our solar system.
Yeah.
But before we go to outer space, we got to get spaced out. So, what's your poison?
Oh, that was a good intro.
That was a very good
I shouldn't have doubted you.
People just kept interrupting.
I know.
We shat all over that intro.
Sorry.
There are also planets you used to date.
Fuck you! I was gonna make that joke.
Fuck, goddamn it.
You're going to hell even faster than before.
Damn it, you have control over that?
Sure.
Oh, shit.
I do now.
We should treat you better.
Explain that.
Exoplanets?
Exoplanets, yeah.
Could also be the second in command of a submarine, the executive officer, but that's not nearly as fucking funny.
Exoplanets, yeah, I know. Yeah. Would Pluto be an exoplanet?
Pluto will always be a planet.
Yeah. It used to be our planet.
Never a planet. Pluto's
now it's in the planetoid zone.
People that think that Pluto should still be a planet actually go to hell.
Okay, Zoomer.
All right, now we've just lost like half of our listenership because of that comment.
Hey, I'm just telling you the truth. I don't know what to tell you.
We got to appease everybody. We got to please every demographic.
I'm pretty sure that we don't.
So, what's your poison?
Our poison today
is a box of wine from my kitchen.
Yay!
It's Jackson Triggs Malbec. It's $35 at Costco. And it's fine.
It's award-winning.
Now, this isn't like an advertisement. Like, they haven't paid us to say this or promote this. We're just, that was what we happen to have.
I just always buy this wine.
Yeah.
Since 1993, our passion has been crafting award-winning, approachable wines, best enjoyed with those who matter most. Our Malbec is juicy and bold.
Best enjoyed with people who matter the most. And your podcasting co-host.
That's right. Notes of ripe red fruit and blackberry. Pairs well with grilled red meat or your favorite takeout. I just get it because it's cheap and I like how it tastes.
Why don't sponsors like us?
I wonder how this would pair with like Arby's.
Pairs great with everything.
Like it does seem like it would pair great. Like, get a little bit of that spicy, fruity Arby's sauce in there and just, that roast beef with your wine. Oh, that'd be good.
When I'm halfway through this half a solo cup of bad wine, I'm going to add a Rockstar and see how it goes.
It's good.
And the hot sauce people wouldn't call us back? We're not family friendly.
No.
Jackson Triggs Malbec pairings lamb barbecue on its own.
That's how I have it.
On its own?
With more wine.
It does, doesn't it? Wine pairs well with other wine until it doesn't anymore. Yeah. And then it's a mess all over the bathroom.
And then you realize that you're almost 40 and
you're still
oopsie-doops.
Drinking like you're in university.
Yeah.
I know it's supposed to taste different, but every wine kind of tastes the same to me. At least every red wine. Just always reminds me of church wine.
Jackson Triggs itself says that the food pairings are best enjoyed with spicy sausage or meatloaf.
Wow.
I would do anything for love.
Two things that I don't eat.
But I won't eat meatloaf.
No, is there church wine, or does the church go to Costco too?
I don't know. You should find out, because I could fuck with some church wine.
Yeah.
What if it's like the church of Costco?
Oh,
Maybe.
shit.
Could be.
Maybe they're Jackson Triggs. Maybe if you unscramble those letters, it makes Saint Gigagoo or something.
Sacramental wine, so we can buy altar wine from Catholic Supply of St. Louis Inc. Serving faithful since 1960. They come in 1 liter jugs.
Yeah. Could we go to the parable stores here in town where they have wine?
I wonder, or are they Christian?
Well, they're just Christian, but
instead of
have we ever drank holy water?
I don't think we have drank holy water. I'm not going to, because
Well, all you got to do is you just take regular water, you put it on the stove, and just boil the hell out of it. But it's one of these episodes.
It is.
Ooh, a box of fellowship cups, 100 count for $69.99. That's the little grape juice that you get in the little cup.
You don't need that much grape juice.
Why do they need to source it from a specific place?
Canon law. It has to follow canon law.
So, like, nobody that picks the grape is allowed to be an adulterer, or?
No sluts.
Yeah. Yeah. You only bang your husband's wine wenches. That's it.
Oh, man, there's a lot of sites that you can get this. Oh, this one's literally from the Vatican, I think.
Oh.
How much does wine literally from the Vatican cost us?
€7.50.
Wow, that's a lot of money.
So what, like
€7.50 or
like 13
€750?
Yeah.
Euros?
€7.50.
Okay.
So like $15.
Sweet Red Altar Wine by Martinez 100.
Fuck,
Sweet
we need
red.
like legitimate straight like
Let's do
Straight
it.
altar
Catholic,
wine? Or
Vatican
Orthodox wine.
We need like straight up Catholic wine. That's what we need now.
Remember when I stole holy water from that church we drank it? Then we're like, oh, how often do they change the church water? None of us died. That was good.
So we did do a holy water once.
We did.
Oh, there you go.
I stole it from a church. They could just fill that up from the tap and just bless it, I think.
I think that's how it works.
Yeah.
Oh, you have to have more than half before you can water it down. So you just need, like, if you have a liter of Pope water, then you need 501 milliliters, and then you fill it back up to a liter, and you have a liter of holy water again.
It's like homeopathy.
Yeah.
Religious homeopathy.
Okay, I'm going to see how
I'm still waiting
Your
for those
blessing
sleeping
from
pills
the
to kick
original
in.
blessing is just a little micro blessing.
Exactly. It retains the memory of the original
It's
blessing.
like a nano blessing in the whole global water thing.
That's right. You remember when we called and they were like, don't worry about it.
Don't worry. Just drink some water, and if something bad does happen, call 911. But we didn't.
They're like, it's
that was
okay.
a good episode.
It was.
Go back to that episode. Maybe listener, go back to that episode, listen to that one, homeopathy, and then come back to this one and listen to it.
That was like 5 million years ago.
Are we done with the poison? Should we
Sure.
carry on?
Yeah.
It's wine. 5 out
Do
of
we
10.
have more jokes to make? Oh, I got one more.
10 out of
Okay.
10. 10 out of 10
So what
wine.
did the grape say when it was stepped on?
What?
Nothing. It just let out a little wine.
And also, ew.
Yeah.
I didn't like the visual that I got from that.
Yeah.
And if you're a feet person, you're welcome for that visual.
So, for about the next hour, I hope to take you on a fun trip. It's our voyage, as Virgil said in the Aeneid. It's us to the stars, and I hope to take you there a little bit. It's part of my journey. It's part of our journey, and hopefully it'll be part of your journey. This whole world of exoplanets. Now, this whole idea of heading towards the stars is not something new. I would point out to you that this vexing concept about worlds beyond the Earth has been gnawing at humankind and human inspiration and human curiosity now for thousands of years. Epicurus himself said there are infinite worlds, both like and unlike this world that we inhabit. And you might say to yourself, well, where do we start this hunt? Where do we start this exploration looking for other worlds? We start with looking at the stars and taking the knowledge that we have on our own planet and extending that out into space to try to project or expect what we might find. Indeed, what we do is we look at our own solar system, and on the left here is a very interesting picture that was taken by Voyager 1, one of the spacecraft that is your legacy. It's humankind's sort of signal to the cosmos that we're here. This spacecraft has left our solar system to fly forever in the cosmos, to perhaps be found at one point. But one of the interesting things that the Voyager did, in part through the instigation of Carl Sagan, was to turn around and with its imaging cameras take a picture of our solar system and our world. And so this is a montage of the snapshots that Voyager took on its way out. You can see Venus, you can see Jupiter, Saturn, Uranus, and Neptune. And this is the image that inspired Sagan to write that very famous book called the pale blue dot. That's us. A single pixel on a CCD camera on a spacecraft bound for the stars. And so what we have to do is take our experiences within our own solar system and what we know about our own planets. The very famous solar system portrait that was created in 2007 after we had visited a large number of these worlds with spacecraft is take those ideas and go off and begin a hunt for exoplanets that in the back of our mind, many of us had said, it would be kind of lonely that on the third rock from the sun, that would be it. Are there other worlds out there? And if so, what do we want to know about them? And you might ask, well, what is the $64,000 question? I think the $64,000 question that's lurking out there and certainly driving a lot of what we do is an answer to a very fundamental question. And that fundamental question is the following, and I posit it to you this way. Are Earth-like planets rare? Because if they are rare, that has certain, I would say, scientific and philosophical implications. But if they are in abundance, that has some different scientific and philosophical implications.
Exoplanets have been hypothesized about. In 1584, Giordano Bruno wrote, "This space we declare to be infinite. In it are an infinity of worlds of the same kind as our own, observing that the stars are fixed and, like our own sun, must have planets of their own." Mm-hmm. So exoplanets have certainly been written about, largely in science fiction, well before even discovering one, from the planet Vulcan to Alderaan to Skaro to Arrakis and GD Prime. We've written a lot about them.
Yeah.
Even though we didn't know whether they actually existed or if we were just
talking about
an anomaly when it came to planets orbiting stars.
Yeah. And it makes sense. Like, you're down here on Earth, you look up and you see another body in the sky like the moon. It's not hard to imagine, even before any astronomy, like, what if there's other bodies out there with other people on them?
Exactly. So from 1855 all the way up to 1991, astronomers were eager to be the first to demonstrate the first exoplanet, with a few making claims that would be eventually ruled out as false for various reasons. And now we have a vice versa situation. In 1917, astronomer Walter Sidney Adams found what would be evidence of an exoplanet. He discovered calcium while looking at Van Maenen's star, which would later be identified as a white dwarf. So it would be a colder star that had burned off all of its fuel. However, he thought he was looking at an F-type star, which was an actively burning star, so it would be really hot and producing calcium through, nuclear fusion and all that kind of stuff and fission. So he thought the calcium and the other elements he found were being produced by the star. But it turns out that that was not being produced by the star because the star was too old, too cold, and burned off all its fuel. Oh. So the reason why he saw calcium was because it was probably an exoplanet falling into the star, being ripped apart as it moved towards the white dwarf.
Whoa.
That's intense.
So imagine looking at the first exoplanet in 1917 and thinking, oh, it's probably just a star, and not realizing that it was another planet.
Yeah.
But in 1992, the first exoplanet was confirmed, 2,300 light years away from Earth, around a pulsar that orbited planet PSR B1257 plus 12b. Nicknamed.
Try saying that 3 times fast.
Yeah, exactly. They nicknamed it Poltergeist.
Oh,
that's kind of cute.
Yeah, little Polty. Polty, little poultry.
Yeah.
It's a little chicken.
Little Polty.
Little Polty, like kind of Curie. And,
yeah.
This planet, its year around its star is just 66 Earth days. 4 times the diameter of Earth. For comparison, Neptune is about 8 times the diameter of Earth. And today we have 5,834 confirmed exoplanets in 4,356 planetary systems.
Oh my God. That's way more than I thought that there was going to be.
There's a lot of planets out there, people.
Holy fuck.
They put the chemicals in the planets that turn the frogs gay.
It's true. They do.
But how do we find these planets, and how can we know so much about them? So the easiest and most common way we detect planets is observing it pass in front of its star. So as it passes across the star, the light is obstructed and the star's brightness dims temporarily. So think of it kind of like when the moon passes over the sun during an eclipse, but it's a lot less dramatic because planets are a lot smaller, stars are a lot bigger, and everything's a hell of a lot farther away.
So like you're staring directly into a halogen lamp and a fruit fly passes between you and it.
Okay. Yeah, exactly. That kind of thing where it's really bright and this little tiny thing moves in front of it. The light dims temporarily, but
by like a fifth of a percent or something.
Yeah, like you've got to be very, very precise in these measurements. For example, the Earth-sized planet transitioning a star like our sun would cause the star's brightness to drop 0.0008%.
Oh, Lord.
Oh, my God.
So that is how absolutely precise your measurements would need to be to detect these planets, transiting across the path of a star.
Wow.
However, the dimming of the star doesn't necessarily mean there's a planet, and so planets found this way are confirmed using other methods as well that would support the existence of the planet.
Yeah, because it could be another galaxy passing in front, or interstellar gas,
dust clouds, comets, all sorts of shit out there, and you don't really know.
Your coworker fucking with you.
That's right. The guy's like, messing with the machines, changing the settings. Yeah. Maybe you forgot to turn it off and turn it back on again because you don't listen to the IT guy. You know how it is.
It's a so-called transit technique, and transits are nothing new in astronomy. I'll just summarize here and I'll show why they're not new. Here's the star. Here's a planet in its orbit. If the orbit is around like this and we're over there, the planet does not get in front of the star. But if it's orbiting in the plane of your observation, then it goes in front of the star. And if it does that, you look at the star, its light goes like this. It's steady, and then it drops down. If the planet is large, the drop is big. And so by the drop, you can measure the size of the planet. Pretty good. Not bad. Now, this is the primary transit when the star is occulted by the planet. The planet, of course, will go behind the star, and that's called secondary transit. And in each phase, we get interesting information, which I'll discuss. Now, this is a real picture of Venus in 1882 transiting the sun. I don't have a movie, unfortunately. They didn't. Although it might have been possible then. But you can see how small it is. It's not going to make the stellar light blink much. So that blink is going to be very small. So it's something the size of Venus, which is like the size of the Earth, isn't going to give a big signature. You're going to have a good telescope, usually in space. We have them. I'm going to talk a little bit about that. Now, of course, an earlier transit of Venus is associated with Captain Cook's voyage. And he also, everything associated with planets goes badly. He was murdered, of course, in this expedition, but that's a different lecture. So this is what's happening. Planet goes across the star, goes on. And this is what happens to the light curve. And this is the best light curve, one of the best light curves we've been able to get. I'm going to call your attention to a few things. This was taken with the Hubble Space Telescope. Nothing, nothing, nothing. Planet gets in the way. From the shape, we can learn a lot about the planet and something about the star. But look at that number, 1 to 0.985. It's not going down much. And this is a giant planet. You can still, but you can get such data from the ground. This is a tour de force. And we've been able to do this, as I say, for 70 objects.
So the next method is radial velocity. So all things with mass in the universe are pulling on every other thing with mass in the universe. So gravity is pulling Ood and I together, and the Earth is pulling me towards it, and the Sun is pulling me towards it, and the star Arcturus is pulling me towards it, and the Andromeda Galaxy is pulling me towards it, but these last two are much, much smaller in extent.
Yes.
What this means, so while a planet in orbit around a star is being pulled towards the star by the star's gravity, the planet also pulls the star ever so slightly in comparison towards it. So because the star is being tugged by the planet, we can see small changes in the wavelengths coming from the star as it's being tugged around by the planet in orbit. So, kind of think like Doppler effect, how you have an ambulance kind of, it sounds one way as it approaches you, and then it sounds like a different tone as it drives away from you with the siren on. That's the Doppler effect. And so we can kind of watch these stars in their light, and it kind of reacts that way as the gravity pulls the light from the star all over the place.
And just wobbles slightly back and forth.
Yeah, it wobbles back and forth. So like this method will let us find like planets the size of Jupiter several thousand light years away.
Cool.
Yeah. This method is largely how we found other planets up until about 2012. The other way would be gravitational microlensing. So we know that light can bend. For example, you see light bend through a glass full of water, producing a magnifying effect. But gravity will also bend light. So we can thank Einstein for this knowledge. What we will do is we'll use the gravity of one star to see the stars that are behind it. To get a better view of the light from a more distant star. So you would have there'd be a star behind it, but there'd be one star behind another star, but the gravity from the star that's closer to us will bend the light from the star behind it around it. And so we get like a kind of like a big magnifying glass in space that lets us get a closer look at what's going on.
Yeah, you can see the extreme example of that in the movie Interstellar. That it worked with astrophysicists to correctly model what they think a black hole would look like. And in that example, the gravitational lensing would show what was behind the black hole on the front of the black hole, because it curved the light all the way around to the front side. It'd be like if you were looking at Richard Bigley from the front, and you would still be able to see his ass.
Whoa. That's the dream.
Yeah.
That is the dream. It is a nice ass.
Yeah.
It's a nice front, too.
Oh, yeah.
The ass is better.
Yeah. And it'd be lensed to be combined. You see the front and the ass all at the same time.
It's really the perfect picture.
Yeah.
Yeah.
Black hole Bigley.
Yeah. Cool.
Where the hell was I?
How many ears did Captain Kirk have?
2?
3.
A left ear, a right ear, and a final front ear.
Ow. It hurts.
So for the remaining 2 people listening to this episode.
Thanks for staying.
So now basically we can use this star as a lens to see if there's a planet around other stars. The planet's gravity also can lead to observable changes in the nature of the lensing as well, because the planet has gravity, the star has gravity, and the other star in front of it has gravity. So kind of seeing how this lens shifts can help us identify planets. However, the downside to this is that it requires a really highly rare alignment with Earth, the lens star, the exoplanet, and the star that it orbits. So it really makes it difficult for us to do any sort of follow-up observations on this because it's just Earth's moving, the stars are moving, the planets are moving.
The planets need to literally align. It needs to be like perfect.
Stars and planets literally need to align for us to use this method. And so it becomes very difficult to make further observations if this is the method we're using. Yeah. And to be quite honest, this alignment may never happen again during the lifespan of any other human on this planet at all.
Wow.
So it really makes it hard to do that, but it does allow us to detect planets, for example, planets the size of Mars, or planets that are quite a ways away from the star, where these other two methods I mentioned before weren't really usable.
That's getting pretty small and rocky, actually.
Yeah.
Especially since the first one was, 4 times the size of Earth?
Yeah.
And then Mars is a little bit smaller?
And that's why they're detecting so many hot Jupiters.
You're a hot Jupiter.
Oh, thank you.
But
because
I'm just gassy.
Because they were big and close to the star, easy to detect, and that's why there had so many hot Jupiters in the early history of exoplanets. And then as things get perfected, you're able to detect things smaller and smaller and smaller.
That's so cool.
Yeah,
it is.
Do you know what stars get when they lose the galactic talent show?
What?
Constellation prize.
Boo!
Oh, psychic damage.
I'm not looking up anything useful this episode. It's all puns.
All puns is star jokes.
Yeah, 2d4 psychic damage, in fact. Yeah, roll it.
Gravitational microlensing is an effect that was predicted by Albert Einstein, in fact, back about 100 years ago, but Einstein thought it could never be observed because it would be such a rare phenomenon. And in fact, about 1 in every million stars in our galaxy is being microlensed at any one time. What it means is that the star that we can see in the galaxy, there's another star in between us and that distant star. And the gravity of the foreground star actually bends and magnifies the light of the background star and makes it appear brighter than it otherwise would be. Now, because all the stars in the galaxy are in motion with respect to each other, this brightening effect is only a transitory phenomenon that lasts for maybe a few days, up to a few weeks, a few months, where the star brightens and then slowly brightens and then fades away again in brightness. Now, if the star that's actually doing the magnifying, what we call the lens star, if that happens to have planets around it, then that causes an additional magnification or bending of the light. And that's something that we can detect. We do that by observing microlensing events from many different sites around the Earth, around the southern hemisphere, so that we can track stars 24 hours a day. So I work on 2 aspects of this work. One is that I work on the measurements. I work on extracting the individual measurements out of the images that we acquire through our cameras and telescopes. And the other part of the work I work on is through the analysis of the measurements, which is mathematical modelling and analysis of the data. The microlensing phenomenon involves some quite complicated physics, and it involves lots of fairly intensive computer modelling to actually extract out from the measurements any of the physical parameters like the masses of the planets and such things.
What do you think about sort of the future of microlensing? What are you doing there for people?
The future of microlensing. The field of microlensing is changing a little at the moment. So in the past, there's been 2 main experiments that have discovered most base microlensing events, which have then been followed up in more detail in order to get the information about planets and things by lots of astronomers around the world. But we're now changing into a mode where we're going to have large dedicated telescopes for just doing this microlensing work. So one of the new projects that I'm involved in is called KMTNet, and that's a series of 3 1.7 metre telescopes with very large cameras on them that are going to be installed. The first one's being installed and being commissioned in Chile right now, and there's another one going in South Africa and another one going in Australia. So that once those are operating, the data flow from those. They'll be imaging large chunks of the central galaxy at very high cadence. In fact, it'll be imaged every 15 minutes, and that's going to revolutionise our discovery rate. Currently, I analyse data from up to maybe about 20 different telescopes that are all around the world. So there's the 2 survey telescopes, which are called Ogle and Moa, one in New Zealand, one in Chile. And then the collaboration I work with historically was called Planet, and we've operated half a dozen different telescopes in different countries at various times. I also work in closely with amateur astronomers operating telescopes as part of the Microfund network. It's a microlensing follow-up network. And I analyse data from all those sources.
Finally, the other method is direct imaging, so we basically just see it. Planets that are too close to their stars often aren't visible because their reflected light is just mixed in with the star's light, and the planets further away reflect so little light, so we just really don't see them. So much of these discoveries are done using thermal imaging. This method is good for finding Jupiter-sized planets and a lot of large planets that are very close to their stars that they send out a whole lot of infrareds. So 2M1207b was the first planet discovered using this method in 2004.
Beautiful name.
It was. They should just call it the Richard Bigley planet.
Yeah,
or
literally.
something. It could be much easier to remember.
Yeah.
Yes.
And it was 170 light years from Earth, and that's how we discovered is we just saw it when we turned on the infrared, and we're like, oh, look, there's a planet.
Oh, cool.
Because it's reflecting a whole lot of infrared off its own star.
Yeah.
So these various methods will let you know different things about planets, from how large the planet is to how long of an orbit it has around the star. Once we discover an exoplanet, we can use spectroscopy. Spectroscopy.
Oh, I wasn't even saying it right.
Yeah, it's not spectroscopy. It could be spectroscopy.
Spectroscopy. We'll just say it that way.
Spectroscopy.
Spectroscopy.
That's the one.
Whatever.
That's what we need
to learn what's going on.
Listen to the disclaimer, okay?
So what exactly is that?
That word.
Isaac Newton had split white light into all colors of the rainbow using a prism. I'm sure a lot of folks know what a prism is. It's a little piece of glass that takes white light and makes a rainbow with it.
Yeah.
You'll see that in a lot of different things. A lot of lawn ornaments do that kind of shit. Little window ornaments, things like that.
Pink Floyd albums.
Pink Floyd albums, exactly.
Yeah. Dark Sides of the Moon.
Yeah.
Yes.
Yeah.
And so this doesn't just work with visible light, but it can also split infrared and ultraviolet. Ultraviolet.
I should watch that movie again. Ultraviolet.
That's when you say something bad about lights, Mom.
It gets ultraviolet.
Yeah.
Little clockwork star here.
That's right.
And it also works with radio waves and X-rays. So I'll just use the term light to basically describe all of that. Oh, technically it's not light, it's like electromagnetic radiation, but I'll just say it's light for simplicity's sake.
Yeah.
Perfect.
In the 1800s, Joseph von Fraunhofer noticed while looking closely at the rainbow produced by a prism that there were little dark lines at certain wavelengths of light, depending on what kind of element the light was reflecting off of. We now know that atoms will absorb certain wavelengths of light depending on what kind of element it is. And so these dark lines were wavelengths being absorbed by the atoms of whatever was reflecting the light. So you reflect light off of one type of atom or one element and view it through a prism, you'll get one set of dark lines. You use a different element, you'll get a different set of dark lines. And so basically using this, we can see what elements exist in planets, far, 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 far away. So it's, like the Scandinavian Navy, it's basically like an elemental barcode.
Throwback.
There we go. That's a good callback.
Yeah,
improvised
to earlier this episode.
Yeah.
I'm still giggling at Fraunhofer.
We're the only
that's a great
podcast
name.
that make you suffer through dad jokes twice.
Who cares about this elemental barcode and spectroscopy?
I do.
Spectroscopy.
I do.
Okay, good.
Good.
See, well, if this information is all kind of put together, the planet size, the distance from the star, the type of orbit, the chemical characteristics, we can use this information to look at planets where life may have developed. For example, Kepler 22b, 640 light years away from us, is about 4 times the size of Earth. But if it doesn't have an atmosphere, its surface temperature would be about 6 degrees Celsius. It's thought that it could maybe be a water world.
Cool.
Just a giant ocean and its surface with a small little rocky core. And if there is an ocean, there's a chance for life. Accordingly, SETI has turned its attention to studying this planet for any indications of life. SETI is the search for extraterrestrial intelligence.
Kevin Spacey will be there.
Yeah.
No, who's
Kevin Costner?
That's the one. Oh,
Kevin
yeah.
Spacey touches boys.
Jack Black was in Waterworld?
Shut up.
Wait, Jack Black?
As Smoker plane pilot.
Oh, my God.
Ah.
I have to watch that movie.
Never seen a Waterworld?
No, watch it again.
Okay.
To look for Jack Black specifically. No, that's fair.
The star TRAPPIST-1, about 40 light years away, could
Star TRAPPIST-1?
What?
Is that what you said? Star Trap? Like
it's literally called, no, the star is literally called TRAPPIST-1, TRAPPIST-1.
Oh, okay. Sorry. That just sounded really weird to my ears for some reason.
Yes.
Go ahead. Sorry. I'm sorry. Yes.
It's about 40 light years away. It could potentially contain 4 habitable worlds in its orbit.
Oh, that's good because we're gonna fuck this one up.
Yep.
Earth is going down, dude.
Like, I think it'll probably be one of our first, once we somehow figure out our way out of the solar system, I think that's probably one of the ones we're going to start trying to get to. But
cool.
Sage, if you don't like TRAPPIST-1, you can use this other name, which is 2MASS J23062928-05022285.
Love that one.
Yeah.
So these 4 rocky worlds are all around the size of the Earth. I will call them D, E, F, and G. So TRAPPIST-1E could also be another ocean planet. Planet F actually showed evidence of some water, which was likely found in clouds. And however, it is almost certainly tidally locked, meaning that there would be no day or night on the planet. So basically, the same side of the planet always faces the sun, no matter what time it is.
Weird.
Yeah. And
so it doesn't spin around?
Well, I mean, it spins around, but the spinning around of the planet is equal to the length of the year of the planet, similar to how the moon spins around, but the moon spinning is equal to the same length of time as it takes to go around the Earth.
Right.
So when you're looking up at the moon, you're always looking at the same side, which is why we have a dark side of the moon.
Yes.
Yeah.
Oh, that's weird.
Money.
Depends on what perspective you're looking at it from.
Yeah.
Crazy. But that if it was partially a water world, that means one side would always be boiling and the other side would always be frozen.
Well, that was the water world was a different.
That was a different one.
Oh, okay.
Yeah.
Okay.
So it would have no day, no night, and one side is always facing the star and one side is always facing away. However, there's thought that there might be some water that may exist on this planet, kind of on the kind of the polar region, or like the region where day meets night on this planet. Because if it's facing the sun, it would be too hot and boil away, and if it's facing away, it'll be too cold. But there could be some water in just that perfect zone.
In a very specific zone.
Designate the baby bear portage zone.
Yeah, that's right.
Yeah. So that's kind of an interesting thing to think about.
That's wild.
G is thought to have retained a lot of the steam that existed in primordial times, and so likely has a lot of oceans today and an atmosphere full of oxygen. Now, Planet D, scientists are somewhat mixed on if it could support life, and models suggest that it might actually be more like a Venus-type planet, where it's just hot and the steam in the clouds just keep trapping more and more heat, producing more and more steam, and then you have that like runaway greenhouse effect. So it's probably a very, very hot planet. Similarly to how like Venus has those thick clouds that just trap all the heat from the sun, and it's also a very hot planet,
which we might actually be able to colonize at some point.
Yeah.
Shut up, really?
The idea being that there's a certain point in Venus's atmosphere where the pressure is atmospheric pressure, like 1 atmosphere.
Yeah.
And you could have a floating city in Venus, and the only thing you'd really need is just like a suit that stops all the garbage poison from hitting you, and like an oxygen tank that you breathe. You don't need like an exosuit or like an EVA suit. You just need to not get poisoned.
Cool.
Yeah.
Neat. So it'd be like that floating cloud city in like, what is it? Empire Strikes Back, right? That's the one with the cloud city?
I think so.
Yeah, that'd be cool.
I can't remember if it has something to do with the fact that the clouds are so dense that it's more buoyant too, or if that's just in my demony brain.
No, I'm not an engineer. What about like a really big can of Febreze? Because it purifies the air.
Sorry, real quick. TRAPPIST is a project called the Transiting Planets and Planetesimal Small Telescope. Because NASA's really good at shoving names into something pronounceable.
So this Venus-type steam planet, Planet D, is also smaller than Earth, and it also likely doesn't have a magnetic field, which would basically allow the star to blow away a lot of the gases that it may have had once. But if it does have a magnetic field, or maybe there's some sort of planetary dynamic in there, like volcanoes or whatever, it could help heat exist in all the right places here to form life. The TRAPPIST-1 star is the star with the most known planets within the habitable zone of a star, which is also known as the Goldilocks zone, where it's not too hot, not too cold, it's just right.
That's so neat.
Yeah.
Whoa.
Rockstar and wine is good.
Yeah.
Oh no.
It's also good if you put, oh, Jesus Christ. It's also good if you put Coke in it.
Yeah.
No.
Fucking love wine.
Cocaina.
Fucking love wine and Monster. I'm going to punch holes in this drywall.
Okay.
Going on your finance.
Booger sugar, as it were.
Coca-Cola.
That's why Kyle puts holes in the drywall.
Oh, Coca-Cola. You mean, I fucking love finance.
How do you get this burger and fries out so fast? Cocaine in the kitchen, kids.
Yeah.
I'm excited to announce today that Dr. Michael Gion and his team have used our Spitzer Space Telescope to determine that there are actually 7 Earth-sized planets orbiting the nearby TRAPPIST-1 star about 40 light years away. What's more, as you can see in this illustration, is that 3 of these planets, marked in green, are in the habitable zone, where liquid water can pool on the surface. In fact, with the right atmospheric conditions, there could be water on any of these planets. So for the first time, we found as many terrestrial planets around a single star, and that's the first time we have been able to measure, in addition to that, both the masses and the radii of these habitable zone type Earth-sized planets. The discovery gives us a hint that finding a second Earth is not just a matter of if, but when. Scientists believe, actually, that around every star there could be 1 planet. Take 3, take 5, take 7, and you can just imagine how many worlds are out there that have a shot to becoming a habitable ecosystem that we could explore.
We used a Spitzer Space Telescope with other ground-based telescope to discover around the same star, not 1, not 2, but 7 Earth-sized planets. And the star itself is what is called an ultra-cool dwarf, which is the least massive kind of stars that exist. And these stars are much smaller, much cooler than our Sun. And still, they are very frequent at the scale of our galaxy, more frequent than solar-type stars. And if you look at this illustration, you see the comparison between a basketball and a golf ball. Well, in our case, the basketball would be the Sun, and the golf ball, it would be TRAPPIST-1. So TRAPPIST-1 is much cooler, much smaller than our Sun, and so the planets in its habitable zone are much closer to it, very close to it, with very short orbital periods. Furthermore, these planets are orbiting so close to the star that they must be, or they are probably, tidally locked, which means they always face the star with the same side, like the Moon, to the Earth. And so if you look at this animation, you can see a view of tidally locked planet with a permanent day side and a permanent night side. The TRAPPIST-1 planet could be just like this. Now, what is also exciting here about this system is that the planets are so close to each other. If you were on the surface of one of these planets, you would have wonderful view on the other planets. You wouldn't see them like we see Venus or Mars, like dots of light. But as you can see in the next illustration, you would see them really as we see the moon. You would see worlds with, which are very big. You could see the structures on these worlds. They would be as large as the moon and even larger for some of them. So it would be a wonderful view on these planets.
Mikkel and his team have started to put up more telescopes. They call it Speculus, and they're going to, from the ground, use telescopes to search 1,000 of the nearest ultra-cool dwarf stars. One of the reasons astronomers are so excited about it is it's a veritable laboratory for studying planets orbiting very cool, very small, very dim red stars that are so incredibly different from our sun. In fact, astronomers constantly go back and forth about all the excitement about these worlds because they're very easy to study. Other people have fears and concerns, and so we actually get to test many people's theories about these worlds being tidally locked and radiation from the host star and things like that. So hopefully we're counting on Speculus to find more of these systems and planets around these ultra-cool dwarfs, these very common stars that we can study.
So the closest exoplanet is Proxima Centauri b. It's also known as a candidate for life, but models are very inconsistent, suggesting that it's like both icy and it's ocean and it's a rocky planet with an underground ocean. So we aren't 100% sure what we're looking at.
Kind of like Earth?
Yeah, but we think it might be able to support some sort of life. But then there's other models that are like, well, it spent 180 million years too close to the star and boiled away any water into space, which again leaves us with like a really hot Venus like world. So basically, as there's no consistent analysis on this, I would maybe hold my breath about finding ET there.
Yes, fair.
Apparently, Proxima Centauri is a flare star that sometimes just shits out coronal mass ejections, kind of like Earth does, but more than we do.
Like our own sun.
Yeah, but worse.
But worse.
Yeah. You know, when you name a star a flare star, it's not like, oh, it's really known for its spots.
It needs 13 pieces of flare.
It needs at least 13 pieces of flare.
I wonder when the sun's going to knock us into the Stone Age. It's going to happen at least a couple times, right?
Yeah.
That'll be fun.
Hopefully my kid's dead by then.
Yeah.
Well, that's dark.
Yeah. It's okay. Humanity version 2 will make similar mistakes.
Yep. Similar terrible mistake.
Yeah.
So here's a couple of exoplanets that I thought were pretty cool.
Yay.
PA 99N2 was a gravitational microlensing event. While not a confirmed planet, it would be 6 times more massive than Jupiter. But the cool part about this one is that this would be the very first planet observed outside of our own galaxy, inside the Andromeda galaxy.
Ooh.
So that's kind of how cool that microlensing thing can be, is it'll let us see planets around stars in other galaxies.
Man. That's so cool.
Assuming it is a planet and assuming everything lines up right. But because it's a gravitational microlensing thing, we will be unlikely to confirm that it is a planet anytime soon.
Yeah.
On the topic of planets from outside our galaxy, there are also a few, let's say, edge cases. The star HD 134440 seems to have been captured by our own galaxy after floating free in space, but it has a whole lot of metal, and it's likely absorbed a planet because of all this metal that we've found inside the star.
Cool.
Yeah.
A little cannibal planet.
Yeah, and then we got BD 202457, which also has 2 planets. It orbits our galaxy center in the wrong direction, so it probably joined our galaxy after something, threw it into our galaxy, or our galaxy consumed its original galaxy, or whatever. Basically, everything's going one way. This planet's going against the tide, going the other way around the center of our galaxy.
She's a rebel.
It's a rebel star with a rebel planet, and so it's likely that these also came from other galaxies outside of our own.
Can you imagine the force, like the energy needed to fling a star through intergalactic space between galaxies?
Yeah, no kidding.
Christ, that's like the collision of black holes, like a quasar, maybe. Like, just tremendous energy.
There was
Well, a supernova's a lot of energy, and
That's
it
true,
releases
too.
it fairly quickly, which the blast would, it'd be like a pressure wave off.
And if you're a binary star system, you might be blown away by that. Yeah.
I saw, and I can't find it right now, but I'll try to find it later. There's some evidence that I think we've had 7 different collisions with like smaller galaxies or other galaxies in the past 13 billion years that we've been around. Because there's tons of stars that go backwards from the way the Milky Way goes. There's also a whole bunch of satellite galaxies for us, like just a dozen little tiny galaxies,
Little blobs
hanging out.
Aw.
Yeah.
However, these all planets are actually closer to us than the furthest confirmed planets, so they are disqualified from the distance competition.
Aw.
Yeah. Sweeps 11 and 4 take the title for most distant confirmed planets at almost 28,000 light years away.
Oh my God.
They're both gas giants. Sweeps 11 is about the size of Jupiter, but about 10 times more dense. And it also orbits its star every 43 Earth hours.
Wow.
So, like, you get to ring in the new year just about every 2 days.
Oh, Lordy.
That's too much.
Yeah. We've discovered a planetary object in orbit around PSR J0337 or 1715, and it's expected to be 30% the mass of the moon.
Wow.
Yeah, so it's this little tiny thing that's kind of like a planet, but like
from so far
a lot
away.
less dense than our own moon is.
Yeah.
It's a baby.
Just a little guy.
Of course, not to confuse mass with size, Kepler 37b is slightly larger than Mercury, but is slightly smaller than our own moon. And luckily for it, size isn't everything.
No.
It's how you use it.
Maybe it's made of styrofoam.
And if you think you don't have enough hours in a day, don't look to Beta Pictoris b. This is the first exoplanet we could actually measure its rotation on an axis, and its day around its own axis is 8.1 Earth hours.
Oh my God.
Oh.
Like a work day?
Yeah.
Yeah. So like it's just every 8 hours it's a day on that planet.
That's wild.
But it's also cool because people smarter than me have also suggested that this planet has an exomoon.
Whoa.
The first moon outside of our own solar system that may be observable.
That's cool.
670 light years away, we have Kelt 9b at a surface temperature, a balmy 9,897 degrees Celsius or 17,846 degrees Fahrenheit. And it is the hottest planet. It is 2.8 times the size of Jupiter, and a planetary year is less than 1.5 Earth days. So it goes around its star every day and a half.
Just rips around.
Just ripping around there. This planet is so hot on the day side because only one side of the planet would face the star due to the tidal locking I was talking about earlier. It causes the molecules to actually break apart into individual atoms because it's just boiling. And so the planet probably has a tail similar to a comet does as it orbits its star.
Whoa.
Because it's boiling the planet away.
Yeah. Oh my gosh.
Gliese 900b has a year of 1.27 million Earth years.
Wow.
And it's about 12,000 times the distance between the Earth and the Sun from its own star system. And it actually orbits around 3 stars. And it is called a circumtriple planet.
Whoa.
So it is really, really far away from the center of its solar system. And at the center of its solar system are 3 stars.
Wow.
And it orbits all 3 of them.
Oh, no. That's where the Trisolarans are from. Fuck.
And Tatooine only had 2 suns.
Yeah.
Yeah.
That was complicated.
How many astronomical units away?
12,000.
Jupiter is 30.
Fuck.
So 30 times the distance, and this is 12,000. So.
Jesus.
Yeah.
Yeah, Pluto is 39 astronomical units.
And that's why it's got a 1.27 million year long year.
Wow.
Or I guess orbit around the center of its solar system.
Nobody has their driver's license.
The star Kepler 90 has 8 known planets in orbit around it. So that star is a very, I guess in terms of makeup of solar systems, it's got the same sort of number of planets as our own.
It's been busy.
It is busy. Now let's take a bit of a trip in our minds here. We're going to use our imagination and travel to an exoplanet. So we're going to go to a unique world, HD 189733b. Now we have our impenetrable climate and gravity controlled spacesuits, so we are impervious to any sort of natural forces or phenomena that exist on this planet. So we finished our 65 light year flight and, made incredible time across the interstellar void. It's 11% more massive than Jupiter, and it's 11% larger radius than Jupiter as well. Now it's orbiting its star at 340,000 miles an hour, or 152,000 meters per second, or 0.0005 times the speed of light.
Wow.
It's clipping along.
Yeah.
For comparison's sake, Earth's orbital speed is about 67,000 miles an hour. So this planet orbits its star every 2.2 Earth days.
Jesus.
Yeah. The star it orbits is an orange dwarf, causing its atmosphere to evaporate. This orange dwarf star is also paired with a red dwarf in orbit. We observe the other bodies in this system, finding new planets. We hypothesized about this system having other planets based on the erratic timing of this planet's transits across the stars, but we didn't confirm any planets until we just took this imaginary trip just now. Now, this is a large, deep blue orb that stares back at us. It's described as cobalt blue. Despite this name, this blue comes not from cobalt, but from the superheated silicate in its atmosphere.
Whoa.
As we descend towards the center of this gaseous planet, it begins to rain. Not water, but superheated liquefied silicate. Silicate is basically the main component of glass.
Yeah.
Oh.
So it's like this warm glass rain raining down at us at 100 or at 1,000 degrees Celsius in a really thick reflective cloud.
At least we have those suits.
That's why we have these suits. Now this molten glass rain blows at us sideways in the strong winds of the planet at 5,400 miles an hour, or at about 2 kilometers a second.
I hope that we're bolted down somehow.
This atmosphere contains sodium and potassium, components from different salts. There is also carbon dioxide. The atmosphere also contains considerable amounts of water vapor. Now, this is exciting because if water can exist here in enough quantity that we can see it on a planet that's like this, it means it could likely exist in a lot of other places too. Perhaps places that are a lot more friendlier than the glassy...
Than the glass rain place?
Wind, insane wind.
Yeah.
I think I'm going to have to take this idea back to the boss. Like super windy glass rain?
Yes.
That could be its own circle of hell.
I already don't like going to like Swift Current because it's too windy.
Let alone glass.
Yeah, let alone glass wind. Rain wind.
Well, and Winnipeg's so windy too.
Ew.
And it's not even near this kind of wind.
No.
Yeah, exactly. And I don't like going there because it's too windy as well.
Exactly.
Yeah. If water can exist on that, well, it means water could probably exist on a lot friendlier planets, which could perhaps support different types of life.
And so now, after less than 3 decades of this work, first discovery 1995, we have over 5,300 exoplanets, but many are probably not habitable. I think biology could not exist on many of them. And the exoplanets found, all 5,000, are mostly within a few hundred to a few thousand light years. That's our backyard. The Milky Way is 100,000 light years across, but it's enough to extrapolate, and these are the numbers that are projected. And you can see that 1 in 6 stars has an Earth-like planet, and another 1 in 5 has a super-Earth. And the best guess of biologists is that slightly larger and more massive than Earth planets are just as habitable as Earth's. And they're actually the most abundant kind of planet you can see. The solar system doesn't have a super-Earth. Earth and Venus are almost twins, and then you jump up to Uranus and Neptune. So our solar system is a little unusual. Well, you add those two, and you've got 1 in 3 stars in the Milky Way with a habitable planet. That's extraordinary. And that's the raw material. What about the ingredients for life? Computations suggest what the water content will be, and those simulations suggest that the Earth inventory of water is not special. In fact, the Earth is even a slightly dry planet for its size, because simulations find water content that's 10 times the Earth's oceans or 100 times the Earth's oceans. So there's plenty of water out there if water is a requirement for life. So what's the next phase? Having found lots and lots of exoplanets, how do you get to the next phase? How do you find life? Well, you look for what are called biosignatures or biomarkers. So the experiment is simple. You look at the atmosphere of that planet. You can't really see the surface. You can't look for things on the surface. They're too small. You look at the global atmosphere and you look for alteration of the atmosphere by biology. And by reference to the Earth, that might be chlorophyll, which plants have, which creates an edge in the spectrum, and in very particularly oxygen and ozone, which create great absorption troughs. Those are biomarkers. Methane, also a biomarker, produced mostly by life on Earth. But oxygen's the good one, because the 1 part in 5 of the air you're breathing that's oxygen was produced by microbes billions of years ago. It's a total tell for life. Because if the biosphere of the Earth shut down overnight, just do the thought experiment, all life on Earth extinguished overnight, then that 1 part in 5 oxygen, 18%, would disappear in 5 million years. Blink of an eye geologically, because oxygen is so reactive. It'll rust things. It'll dissolve in seawater, making it acidic. It'll bind with rock, and it'll be gone. And so logically, if you see free oxygen in an atmosphere, it must be sustained by biology. So you take the light from the star, make a spectrum, and then you take light that's filtered through the atmosphere of the planet from the star and imprints absorption on it. And so you have 2 spectra. You take the difference, and the difference is what's in the atmosphere of the planet. And then you try and match those features with things you know, like oxygen, ozone. I mean, in this case, you're matching it against something like water, which you expect to be there, water vapor, and you're matching it, in this case, with methane. But it could be oxygen, ozone, other biosignatures. And you can go beyond that with these spectral methods. You can also look for advanced life. You don't have to look for just microbes. You could look for something like nitrous oxide, which is an industrial pollutant. So you could look for things that only humans and civilization and technology produce that are chemicals, and that's a tell for technological civilizations. So the same data will be used for that experiment too. Don't know if it'll succeed. If it's successful, game on, biology elsewhere. If they fail with the first few dozen exoplanets, we might decide, if they're all habitable but have no evidence for microbes, maybe life is not as easy to form as we think it is. And so this is the question now. We're framing a question. We're jumping ahead because we haven't found life anywhere else, so we're getting ahead of ourselves, but why not? And we're asking, are we alone?
I like this shit. I hope that technology keeps on developing. I know you know who has like shut down a bunch of NASA shit, and a bunch of satellites have gone offline. But like maybe after this bump in the road, we can continue to keep on finding and advancing.
Yeah,
that'd be nice.
Yeah,
it's important because Like Ood said at the beginning, we have pretty much killed our planet already.
Yeah.
Gotta start looking for a shiny silver medal.
Yeah.
With glassy rain
With
at 2
glassy rain
kilometers
wind.
a second.
Yeah.
Okay. We'll build a good roof.
That's right.
A good roof on our shed. Our little homestead will have a good roof on it.
Yeah. Cows are going to die.
Why is the moon constantly moody?
Oh.
Why?
It doesn't really matter. It's just a phase.
Oh.
Boo.
Aw.
And that was the last listener gone. So I'm Richard Bigley, and I haven't written an episode in over a year, so I don't know if I still got it. You can email me at richard@ovpod.ca or yell at me on Blue Sky, richard.ovpod.ca. Yeah, I guess that's my episode. Subscribe to our Patreon. It'll be really nice.
Yeah.
We like money, and if you send us your money, we'll like you.
Yeah.
So sign up for our Patreon too.
Yeah.
And in studio with me, I've got
Sage Murray.
Ood Gallifrey.
Peace out.
Oh, the soundboard team.
Oh, sure. Just ignore the soundboard demon.
Yeah, that's right.
Oh, jeez.
He's going to lengthen our hell stay. We have to be nice.
All right, love you. Bye.
Bye. All good.
How was that?
It was good.
Good.
It's a little rocky.
Yeah.
Like an interplanet, a little rocky.